Hi guys, so today we're going to be looking at angle pairs in geometry, and I listed what the ones we will be talking about today. So we have complementary, supplementary, adjacent, linear pair, and vertical. So let's look at the first set. So we're going to start off with complementary and supplementary angles. So complementary angles are two positive angles whose have a measure of 90 degrees total. So in the very first picture, you can see that here I have that box symbol, and that box symbol we saw before is our dead giveaway for 90 degrees. So I know that angle 1 and angle 2 are 90 degrees together. So I could say that angle 1 and angle 2 are complementary. The box symbol again represents 90 degrees. In the second example for complementary, I have 20 degrees and 70. When I add them together, that is 90 degrees again. So here I can say angle A and angle B are complementary because I can add the two together to make it 90. Notice in the second example that the angles are not connected, and that is okay. Complementary angles do not need to be connected to have the term complementary. All right, the second pair of angles. Down here, supplementary angles. Again, working with two positive angles. This time, their sum will yield 180 degrees. Remember, 180 degrees creates our straight line, so we're looking for a line that is a helpful clue. In angle 3 and 4, if I add them together, that will span the entire picture, creating that long line of 180 degrees. So I can call them supplementary. In the next example, you can see that I have two angles, and when I add them together, their sum is 180. So again, I can call these two supplementary. Remember that they do not need to be connected to be considered supplementary. A nice way I remember between complementary and supplementary is C and S. Now, the letters fall in the alphabet. C comes first, S comes later on. 90 and 180, same thing. 90 comes before 180, so C is 90, S 180. All right, let's try a little bit of practice between these two. All right, so the very first few examples, we're going to identify complementary and supplementary angles using the diagram provided. And then we're going to look at some algebraic problems down below. All right, so we'll do the first two together. So it says GHF is complementary to which angle? So here I'm going to identify this is the angle I'm working with that I'm hovering over, GHF. What angle is going to be complementary to it? So 90 degrees. That box is a helpful giveaway. So this angle next to it will help me create a complementary pair. So how do I name it? Remember 3 letters for our angle, so I would name it FHE. We can put it in reverse, that's okay. So EHF is another name. GHF is supplementary, so we're still starting with the same angle, but we want the supplementary pair. So what angle would I have to combine with this angle to create the entire line? So I would say FHC. Notice how I'm naming with my angle symbol and all my letters are capitalized. All right, I'd like you to pause your screen and try the next two down below. All right, let's look. So what is supplementary to CHD? That is DHG. So CHD and DHG. That's supplementary. And then here we have EHD, and they want the complementary component. So I know that that would be angle DHC. There does not have to be that right angle box right here, since I already know that this right-hand side is 90. That means that this left-hand side will be 90, because remember, we're working with that straight line. CHG is a straight line of 180 degrees. All right, so let's look at more examples without diagrams. What is the complement of a 54-degree angle? Complement goes with complementary, so that means that we're looking for the other piece to this part, this angle pair. So 90 minus 54 equals 36. 90 is coming from that term of complement. What is the supplement of a 112-degree angle? 180 minus 112 equals 68. Again, 180 is coming from that term supplement. What is the complement of a 19-degree angle? So 90 minus 19 equals that 71-degree angle pair. All right, I'd like you to pause your screen and try the next few on your own. Pay attention to asking if they're asking for the supplement, which is supplementary, which is 180, or complement, complementary, which is 90. All right, so the next one, they're asking for the supplement, so I'm subtracting from 180. My other piece or angle is 99 degrees. Still continuing asking for the supplement, so 180 minus 145 equals 35 degrees. 180 minus 145. And I like to show my work so I know what I'm doing for my calculation. The next one is the complement. So that's 90 minus 76, 14 degrees. Then we have 90 minus 37 equals 53. And then we have the last one is a supplement, 180 minus 18, which is 162 degrees. All right, then we have two algebraic problems. So let's look at what they look like. So it says angle LMN and angle PQR are complementary angles. So the first thing I think about before I continue reading on is that I see a vocabulary term, complementary. So I'm going to highlight that, circle it, put it in bold, do something so I know don't forget that key information. Find the measure of the angles when measure of angle LMN is 4x minus 2 and the measure of PQR is 9x plus 1. So I know that these two angles together are complementary, which means when I add these two together, they're going to be 90 degrees. So I can create an algebraic equation. I can take those two expressions and add them together to equal 90 degrees. So you can see here 4x minus 2 plus 9x plus 1 equals 90. So we're going to simplify and combine like terms and solve for x. When I solve for x, I get x equals 7. I am not finished because it actually asked me to find the measures of the angles. So I am going to substitute in 7 for each one of these angles. So 4 times 7 minus 2, find that answer. And 9 times 7 plus 1, find that answer. And then I write my angle measures. So the measure of angle LMN is 26 degrees, and the measure of PQR is 64 degrees. All right, let's try the next one. The next one is very similar, so I would like you to pause your screen and try to set up your equation first, and then we'll go from there. All right, so your equation should be 7x plus 13 plus 25x plus 7 equals 180. 180 because they're asking for a pair of supplementary angles. All right, so pause your screen, solve for x. All right, so when you solve, you should have x equals 5. And now we're going to plug in our x value and figure out the measure of angle 1 and 2. Pause your screen, find those angle measures. All right, so measure of angle 1 is 48 degrees, and the measure of angle 2 is 132 degrees. So now let's look at some more angle pairs. All right, so here we have 3 more angle pairs. We have vertical angles. And vertical angles are two angles formed by intersecting lines, and they're opposite each other. So here in this problem, you can see which two are opposite. 1 and 3 are opposite, 2 and 4 are opposite. And there's something really specific with vertical angles. They are always congruent. They have the same measure. So sometimes they might be opposite angles in a diagram, but they're not going to be vertical. Vertical really means that they are going to be opposite one another and have that same measure. So not only can I say that 1 and 3 are vertical, I can say that they are congruent to each other. They have the same value. That would allow me to add curve markings to my diagram to show those relationships. Now we're going to look at adjacent angles. It says two angles that share a vertex and a side, but no interior points. So adjacent angles are like neighbors. They are right next to each other. So I can say in this diagram, 1 and 2 are right next to each other. Angle 1 and 4 are next to each other. Angle 4 and 3 are next to each other. Angle 3 and 2 are next to each other. Those are all adjacent pairs, which I have listed here. Notice I didn't say anything about 1 and 3. 1 and 3 are not adjacent. They're across from one another. That is not adjacent. 2 and 4, they are not adjacent. They have to be next to each other. So you have to make sure they are right next to each other, sharing a common side. All right, linear pair. Linear pair, looking at this diagram that I have here, very similar to the previous problem we saw on supplementary. So here, linear pair actually is an extra step. It is adjacent angles, so that means they're right next to each other, and they form 180 degrees. So linear pair is not only adjacent, but supplementary. So it's a different way to describe an angle pair. So we're going to see more of what that looks like on the next few slides. All right, so here in this slide, it says identify all the linear pairs and all the vertical angles in this figure at the right. All right, so let's start off with linear pairs. We want to find two angles that create 180 degrees and they are next to each other. So what two angles will do that? So here I always start with 1 and work my way around. So can 1 and 2 form 180 degrees? No. How about 1 and 4? The answer is yes. Now notice I'm not saying 1 and 3 or 1 and 5 because we're asking for a linear pair. That means it has to be next to and equal 180 degrees. 1 and 3 are not next to each other, and neither is 1 and 5. All right, so we have 1 and 4. Now I want to find a different pair. So I'm going to go to 4. We already said 4 and 1, so I'm not going to write that. That's a repeat. But what about 4 and 5? If I cover my paper at the top part and I only look at 4 and 5, you can see that 4 and 5 are a linear pair. Those are my only two linear pairs in this diagram using two angles. Now vertical angles. Remember, vertical angles are across from each other like a crisscross, and they have the same value. So let's look at angle 4. Is angle 4 across from 2 and congruent? The answer is no. What about 4 and 3? Again, still no. They do not have the same value. But what about 1 and 5? They are across from each other and they are congruent. So we only have one pair of vertical angles here. All right, so here the next one, it says we have two angles that form a linear pair. And the measure of one angle is 1/2 times the measure of the other angle. Find the measure of each angle. So the thing that sticks out here is the term linear pair. So linear pair means what? Linear pair means that I am having 180 degrees. So now we're going to set up an equation to help us figure that out. So we're going to use our x variable to help us figure that out. We are working with two variables, and then we are going to create our equation. So I know that angle 1, I'm going to call that x. And angle 2, I'm going to call that 1.5x. All right, so I'm going to stop there for a moment and explain. All right, so it says two angles form a linear pair. So again, a linear pair is really important. It says the measure of one angle is 1/2 times the measure of the other angle. We do not know what this other angle is, so that's why I'm calling that one x. But we do know that the second angle is 1/2 that times the amount. So I know that angle 1 and angle 2, when I add them together, it's going to equal 180 degrees. So here I have x plus 1.5. X equals 180 degrees because of the term linear pair. All right, so then we're going to combine like terms. So here I have 2.5x equals 180 degrees. What is x? So we're going to divide, and when we do, we get 72. Am I done? The answer is no, we're not done quite yet. They want the measure of each angle. We only found the measure of angle 1. We need the measure of angle 2. So angle 1 is 72, and angle 2 is 108 degrees. I did that by plugging in 72 into my problem here. 1.5 times 72. All right. Continue on for some more practice. All right. Before I give that practice, I have to finish off with one more piece of information. Looking at these two diagrams, are these diagrams the same? Can you conclude the same information? Do they look the same? Well, they kind of look like the same diagram. They have the same letters, the same figure, but one has some red markings and the other one doesn't. So the answer is no. I mean, the one on the left over here that I'm hovering over, I can tell you that I have some angle relationships. I can see that I have a straight line. I have a linear pair. I can tell you that I do have a complementary angle. But that's really all I can say. I really can't say much else. On this diagram, though, I can say a lot more. I can say AB is congruent to BC because of my tick marks. I can say ABD is a right angle because of that box. I can even say ray BE is an angle bisector because these two pieces are cut equally in half because of these markings. So markings make a whole different ballpark for us of information. So we really want to pay attention to the markings. And a big piece of information is that the markings are typically given to us either already on the diagram or through given information. We do not add markings because we feel like it. So please pay attention to the markings. All right, so let's now look at the practice. All right, so now down below, I am giving you 2 pages of practice. So I'm going to ask you to pause your screen, and then I'm going to show you the next page. And then afterwards, you'll see the answers pop up. All right, so for 1 to 6, you're going to identify if you have supplementary, complementary, vertical, or adjacent angles. And then you're just going to classify. 7, 8, and 9, they're asking you to identify pairs of angles. So in number 7, supplementary angles, 8, vertical angles, and 9, complementary angles. So it's just highlighting our vocabulary. All right, so pause your screen, complete these problems, and then we're going to complete a few more again, and then I will show my solutions. All right, next page. So here, again, you're going to pause your screen and complete 7 through 18. This side is a little more algebraic, and you're going to find the missing values of the numbered angles. So some of them may require for you to set up an equation, and some may not. All right, pause your screen and find your solutions. All right, here are the solutions. So for number 1, we have vertical angles because they're across from one another. Number 2, adjacent and supplementary. Now, here, the only reason I'm writing these terms is because that's what's asked of in the worksheet. The better term for number 2, which I would put a star on, I would call this a linear pair. So whenever I can say it's adjacent and supplementary, that means I can call it linear. All right, number 3, we have adjacent. They are next to, but they do not have a sum of 90 or 180. They're just next to each other, so it's just adjacent. Number 4, we have vertical angles and complementary. We're looking at A and B. That is all they are, so that's what I'm leaving it as. All right, number 5, we have adjacent and supplementary. Again, because I can call it adjacent and supplementary, it's another way to say linear pair. Number 6, they're next to each other and they have that box, so I know it's 90 degrees. That's complementary. Number 7, now notice it says example. It doesn't say all the answers because there are multiple answers for 7, 8, and 9. So I'm only listing one example for one pair for each. So if you have a different pair and you're not sure, just let me know. All right, so here it says name a pair of supplementary angles. So I'm looking for a pair that's going to give me 180. So right here, GH did the job. Angle G and H will create that linear pair straight across. Name 2 pairs of vertical angles, so J and H. So J and H, just like G and I would have did it. The same thing. All right, name a pair of complementary angles. Angle C and D. Notice angle B by itself is 90 degrees, so be very careful on that. F and A would have been okay, but not angle B. Angle B would not, and angle E would not. All the other angles here would not because we do not have any information to say that they would create 90 degrees. All right, and the last page. All right, so here are my solutions for 7 through 18. When you get to 13 and on, it doesn't show the setup for the equation. It only shows the angle value. So if you have any questions, please feel free to let me know. All right, guys, talk to you soon.